So what's happening here is that now I'm going to be proving this. This is what I'm going to be proving, because when I read online, it doesn't explain as clearly, and it took me a few days to understand. So now when I'm understanding, I record it for my own personal purposes, and I also put it on YouTube and everything so that you all can understand this concept easily. So first of all, I have a circle drawn in the middle of the surrounding the origin, where this is 1 unit, this is 1 unit, this is 1 unit, and this is 1 unit. Basically my radius. So no matter where the circle is, if I draw a line from the origin to the circumference of the circle, this length will be 1 unit. So basically now my equation of my circle is x minus 0, because 0 is my origin, and y minus 0 squared equals to my radius, which is 1 squared. So this is now my equation of the circle. Very easy to understand. So now I'm going to draw a triangle to prove this formula. Now I'm going to prove this idea where the coordinates on the circle within the triangle is formed by this great formula: cosine theta sine theta. So how does it work is that now I have an angle of interest. This angle of interest, okay, in blue, this is my angle of interest. This is a right angle triangle. So now I'm gonna find what is the value of C over here. Find the value of C. So in order to find the x value of C, remember this is a straight line down perpendicular to the x-axis. Yeah. So if to find the value of the x coordinate of C, I basically have to find this, the length of AB. Am I right? Because remember, when we are finding coordinates, okay, is actually x coordinate is actually how far it is away from the y axis, and to find that y coordinate is actually how far away it is from the x axis. Okay, you can pause the video, take a minute to understand this concept. Basically how far away it is from the axis. Yeah, pretty easy to understand. Yeah. So now in order to find the x coordinate of point C, basically I have to find the length of this. In other words. So I have to find the length of AB. So in order to find the length of AB, what formula will I use? I will use cosine, because why? Remember, as we've learned the basics of cosine, cosine equals to adjacent over hypotenuse, right? So in this case, no matter what, my hypotenuse is 1, because remember this radius is 1 unit, and this would be 1 unit because it's the radius. This is a property of a circle. Okay, so I will have cosine theta get AB. By the way, theta and angle of interest is used interchangeably for me. Okay, AB, to find AB, I will have to use adjacent over hypotenuse. Let me explain why. Since this is 1 unit, the length of AC is 1 unit. So this means adjacent, which is AB, over AC. Anything over 1 unit is equals to AB. So we have to take a look. We have AB over AC. And we know AB over AC. AC is what's the length of AC? 1 unit. So we'll just write 1. So it's gonna give me AB. So now we have officially proven that I've proved that cosine, my bad, I forgot to write this, theta, cosine of theta here is equals to AB, length of AB. And we have also proved that length of AB is equals to the x coordinate of point C. Now we find the y coordinate of point C. Easy concept also. Sine theta. Okay, when I sine theta will give me opposite over hypotenuse. And in this case, the opposite of theta is BC. And what are we finding? BC is actually if to find basically the length of BC is the y coordinate. Okay, if you think about it, the length of BC is actually y coordinate, because the y coordinate is the distance it is away from the x intercept. So I will basically find length of BC. Now to find the length of BC, remember sine is opposite over hypotenuse. So opposite is BC over hypotenuse AC, which will give me BC over 1, which is equals to BC. So sine theta is equals to BC. Sine theta is equals to BC. So means when I sine theta, I will find the length of BC, which is equals to the y coordinate. So basically, I've concluded and proved that this formula to find coordinate on the circle is formed by cosine theta and sine theta. It's a very simple concept, and this concept works for any triangle within this whole area. So I can draw a triangle. I can draw a triangle maybe like this. No, like this. Something like that. Any will work. Okay, so now, I can draw a triangle like this, and it works. Okay, so now I'm gonna draw a new triangle. This triangle is symmetrical to ABC. It's symmetrical to ABC, and I'll label it so that you can understand. I'll label it in small lowercase letters. Okay, so now I have a new angle of interest here, angle of interest, and the angle of interest is the same thing. So this is equals to this. Both thetas are the same angle. Okay, ABC, they are all the same. It's literally symmetrical. And what do we know about symmetrical stuff? They're opposite. They're exactly the same thing. They are similar triangles. Yeah, they are similar triangles. Yeah. So what happens now is that we have a new triangle. I can form a new triangle. I'll use the color. Oh, there's no more colors. Okay, then I'll use black. Maybe not a good representative. This triangle you see here, I can find, so basically you see the triangle that I highlighted here. I want to find the coordinate of point C. How do I find the coordinate of point C? There's a very easy method, but I will go another method to prove. So this coordinate of point C is still unknown. Coordinate of points lowercase c, small c, is still unknown. So remember how we have proved that to find the coordinate of the point on the circle, it will be equals to cosine theta sine theta. So now I have a bigger angle here, and it works for any angle. Remember, this formula works for any angle. Obtuse, acute, right angle, it works. Okay, yeah. So I have this big angle here. You see this big angle, and what is this big angle? This big angle here is 180 minus theta. This is adjacent angles on the straight line. This is a straight line, and this is theta. So to find this angle, I have to use 180 minus theta. And everybody understand this concept? Can everybody understand this concept? It's a very simple concept. It's just angles on a straight line, adjacent angles on a straight line. So what happened now is that I know this angle here is 180 minus theta. Okay, so to find coordinate of C, which is to find coordinate of lower C, which is this, inside the formula, it will now be cosine 180 minus theta. And okay, I'll write it below. Actually, you know what, I'll cancel everything away. Coordinate of C is 180 minus theta, I have to cosine it, and sine 180 minus theta. Am I right? Can we see how it works? Can we see how it works now? Very easy concept. Yeah. Fine. So as we know, these are symmetrical triangles. It's directly opposite. What does this mean? This means that cosine will turn negative. Okay, let's take a look. I will draw a new Cartesian plane here. For example, I have a point here. This point is 2 and 5, for example. This 2 over here represents this 2. This is 5. I have another one that's directly opposite. This will be negative 2 and 5. They are symmetrical, directly symmetrical, exactly symmetrical. How does this happen? Remember, 5, which is the y coordinate over here, refers to the length of it. Basically refers to how far it is from the y-axis. Yeah, no, it's how far it is away from the x-axis. My bad, just my bad. Okay, sorry about that. So it basically is how far it is from the x-axis. This is 4, this is 3, this is 2, this is 1. This is the origin, which is 0. So it's how far it is away. So the distance doesn't change because it is at the same level in this case. So distance between the x-axis and this point doesn't change. The only thing that changes is the distance between the y-axis. This is positive 2. This is positive 2. This is negative 2. Can everybody understand this concept? Because it goes behind the x-axis, so it becomes negative. Yeah, you can take a moment to pause the video to understand this concept. So as we have seen, as we know, this will essentially be equals to cosine, negative cosine theta and sine theta. I get it from here. This is directly opposite each other, so my cosine can be negative. Sine remains the same because sine theta basically refers to length from away from the x-axis. The two lengths are the same, so essentially sine 180 minus theta is equals to sine theta, but cosine theta is equals to this is my bad. This is my bad. Give me a second. This will basically be equals to negative 4. Yep. Directly opposite. So the x-axis, basically the y-axis, the y coordinate will remain the same, but the x coordinate changes because it's opposite. But we also know another form, and we can rewrite the coordinates in this form, as we just found out. We just found out this formula. So it's the same thing. So now we can state that negative cosine theta is equals to cosine 180 minus theta. You can always switch the negative sign. No worries about that. You can switch it over. Okay, maybe it's a bit too messy. Yep. So I can maybe I can now say that sine theta equals to sine 180 minus theta. Sorry for the hiccups in today's video, but this is basically the concept. It's very easy, very straightforward. Yup. So I've now proven what I want to prove in the beginning of this. If you still do not understand, leave a comment down below. I'll get right into it very soon. Yeah, and these pictures are taken from the websites.